Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of higher derivatives, and basically it is just a process of continuously finding the derivatives. For example, you can go on and find what is the second derivative, the third derivative, fourth, and so on. Now, the definition of second order derivative can be formally given as follows. So here, let's say we have a function y equals to fx, and this is a differentiable function. Therefore, the derivative of this is going to be denoted as f prime x. And f prime x here is also a function. So therefore, f prime x can have derivative of its own, and the result here is going to be called the second derivative. Now, other common notations are given by this one, which is y double prime, or this one, which basically says that here is the result of the first derivative, and we will supply the result to this operation, where the result of this is going to give you the second derivative of the function fx. Other common notations are this one and also this one, yeah. Now, in a similar manner, you can mathematically denote the third derivative as this one, or for example this one here, where you can see that in the bracket here is the result of the second derivative, and you will supply the result to this operation here. So if you differentiate the result once again, the answer is representing the third derivative of the function. So other common notations are this one and this one, yeah. Now you can go on and find the nth derivative, and basically the nth derivative means you will be differentiating this function n times. Okay, so the notations are given as such. Okay, so now let's look at some visual interpretation for lower order derivative. So lower order derivative means first derivative and second derivative. Okay, so lower order. Higher order could be the fifth or sixth or 10th derivative, for example, yeah. So let's look at the interpretation of this. When you talk about the first derivative, the mathematical notation is f prime x, and here it tells you how fast the function, so function here means fx, how fast fx is changing with respect to x. So in other words, it gives you the slope of function fx at the specific point x here, at this point where your value is x. This is the value of y, which is fx. So f prime x gives the slope of function fx at that point, yeah. Now let's see that this is the graph for fx, and the red one is the graph for the first derivative, which is f prime x. Now I'm just going to explain, for example, this part here. Just going to look at this part. I'm just going to explain what is going on this part of the graph, okay? And I think after understanding what's going on here, you will be able to understand the whole graph, the whole meaning and interpretation, okay? So here, if you look at the graph of this function fx, the graph is moving upwards, and at one point here it is going to reach the local maximum point. And if you can see that the graph here, if you are able to construct the tangent at every specific point. For example, at this point here, the tangent is like this. At this point, for example, if you construct a tangent line, it's going to look like this. At this point, it is looking like this. Maybe at this point, it looks like this. And when you reach this point, you will have a slope that looks like this. The tangent line here is going to have slope 0 because the line is horizontal, yeah? And you can see that at these specific points here, the slope starts from being steep to a bit flat, flatter, more flat, and it gets to 0 here. The slope here becomes 0. So the process here, the value of the slope here is translated into the rate curve. For example, at this point, you will see that the value here is the highest. Okay, so this is the rate curve here is the value of the slope of fx. So you can see that the slope here is very steep, which is the steepest. So the value here is the highest. It is a positive value because the slope is a positive slope. Okay. Now at this point here, this point, this is the value of the slope. It gets lower a bit, and you can see that at this point here, point -2, the rate curve here has a value 0 at this point to denote that the slope is 0, the slope of the function is 0. So for that reason, the curve for f prime x is looking like this. It is going downwards, and at this point here, it will become value 0. Okay, now let's focus on this part, on just this part. Okay, I hope you do understand why the curve for f prime x has negative value. That is because you can see that the blue curve here is going downwards, and if you construct the slope on some specific points, for example at this point, the slope is negative, it's going downwards. Therefore, at this point here, you will have some negative value. If you construct the slope here, it is also a negative slope, and at this point, you'll get some negative value here. All right, and the process continues on. You can see that throughout this part here, the rate curve has negative values because the original function here is going downwards. So the slope here are all negative, yeah? The slope or the tangent lines on the specific point here are going to be negative, the slope of the tangent lines. And at this point, the slope of the tangent line is going to be 0, and therefore on the rate curve here we get 0. Okay, so basically that's the whole process. Now if you look at the next part, which is the second order derivative, well, for this part here, the interpretation is that it tells you how fast slope of the function fx is changing with respect to x. Now slope of the function fx is also the same thing as you're talking about f prime x. So it tells you how fast f prime x is changing with respect to x. Now for example, at this point here, this is f prime. So at this point you will see that the slope of the tangent line here is equal to 0. So therefore we've got 0 on this. On the black straight line here, you got 0 for this one. And at this point, for example, if you construct the tangent line at this point, well, the tangent line has a negative slope. So here we get some negative value. Similarly, for this point, if you construct the tangent line here is going to have a positive slope, so therefore we got some positive value here, and at the end of the day you can construct the graph for the second derivative, which is given by the straight line. So you can see that basically the graph here will get less complicated or looks more simple when the derivative is higher. For example, this is the graph of the original function, and it gets simpler when you find the the first derivative. So this is the result of the first derivative. The graph here is simpler because this is just a quadratic graph. And then if you go on and find the third derivative, the graph here becomes just a straight line. So as you can see here, the graph gets simpler. You can see the graph gets from this complicated polynomial graph, it becomes a quadratic graph, and then it becomes just a straight line graph as the derivative gets higher. Yeah, okay, now let's look at some example. So here we have this function here, and you are asked to find the second derivative of this function. Okay, right, let's start off with finding what is f prime x, which is equal to dy dx, and y is x cos x. Okay, so here we can see that this part you can call it f, and this part you can call it g, and we can apply fg prime plus gf prime and solve for the derivative of this function. Okay, so the result here is going to be x negative sine x plus, now g is cosine of x, and if you differentiate this you will get equal to 1. So the answer is negative x sine x plus cos x. Okay, so this is the result of the first derivative. Therefore, if you want to find what is the second derivative, this is just applying the result here to this process. I'm just going to write down the result is negative x sine x plus cos x. The result of the first derivative is applied to this process here, and later on you will get the result for the second derivative. Alright, so this is equal to negative x sine x. Okay, I'm just taking negative 1 out, plus the derivative for cosine of x. Now in a similar manner, of course, you can think of this as f and this one as g. Okay, and we can find the derivative of that function, which is going to be equal to negative x. So you differentiate this, you will get cos x plus, this is sine x. Differentiate this, you get equal to 1. So I'm just going to leave it as it is. Now differentiate this, you will get negative sine x. Okay, so let's simplify the answer that we got here. So we have negative x cos x minus sine x minus sine x, and that becomes negative x cos x minus 2 sine x. Okay, that's the answer for this question given here. Okay, now let's move on to this question based on the graph here, determine what is f prime and f double prime. So here is the original function, the first derivative and the second derivative. Alright, so I think the best starting point is for us to try and determine where is the horizontal tangent. So for example, if I look at this function here, I know that the horizontal tangent is going to be somewhere here. So I know that the slope here is going to be 0, and I expect at this point I will get 0 value. So my 0 value here is given by is situated on the blue curve. So somehow I can guess that the blue curve here is the derivative of the red curve. If you're not quite sure, we can go on and check other points. For example, at this point here, you can see that the slope here is 0. The tangent line here has slope 0. So therefore, at this point, we will expect to have point 0. And this point 0 is again situated on the blue curve. So clearly the blue curve here is the derivative of the red curve. Now I can see that f function is represented by the red curve, and the first derivative is given by the blue curve. Okay, now if we look at the blue curve, this is the point here where the slope is 0, and I would expect that at this point I will have some value 0. So you can see that point 0 is situated on the green curve, and similarly at this point here the slope of the tangent line is 0. So I would expect that at this point I will have the value of 0. You can see that the value of 0 is on the green curve. Therefore, the green curve here is the derivative for the blue curve. So, in other words, the second derivative is given by the green curve. And I hope you can see that as the derivative gets higher, the graph looks less complicated. For example, the red graph here is more complicated. This is the red graph. It is more complicated compared to the graph of the second derivative. So the graph of the second derivative is this one. This is just a quadratic function. Okay. Alright, that's all for now. Thank you very much for watching.